Hi everyone and welcome to week 7. Yeah, it's going by quickly. You're going to have to remember to complete test 2 this week, and then before you know it, we're going to be on top of test number 3. So since we've been starting to work with solving equations, I want to go over some of the important steps so that you can get a good handle on that. And this is Chloe, my pussycat, and she's going to help me to solve equations. This form is actually attached to this discussion so you can print it off for yourself. And the first thing we want to do is to make things easier with your equation. And one of the things that we'll do start with is if there are parentheses in the equation, you want to clear them. And the way we clear them, the reason there are parentheses is because it indicates that we need to multiply. So here's an example where we have an equation with two sets of parentheses, and what this means is we're going to have to distribute. So here's an example. We distribute the 5 to each of the two terms. Remember, we only distribute if there is a binomial or trinomial, a polynomial, separated by a plus or a minus sign. If this was 5 times and then it was a 3x, we would not distribute the 5 to the 3 and the 5 to the x. We only distribute when there exists a plus or minus sign. So here's that example. The other thing that you want to clear out is fractions. Most of you have problems working with fractions, don't like working with fractions, so let's get rid of them right at the start. How do we do that? We have to find the least common denominator. Now, the least common denominator, one of the questions I asked you about was what is the difference between a factor and a multiple? To find the least common denominator, we're looking for the least common multiple of all of the denominators. Now you can find another common denominator. It doesn't have to be the smallest one, but it makes it easier if you use the smallest numbers possible. So here's an example where we have a fraction on the left side and a fraction on the right side. The least common denominator happens to be 6. It's a number that both denominators go into evenly. 6 times 1 is 6, and 3 times 2 is 6. So what we're going to do is convert those two, or find that least common denominator, which in this case is 6, or 6 over 1. Now what we want to do to get rid of those fractions is to multiply everything on both sides of the equation, each term, by 6, or 6 over 1, which is the same thing. So we're going to multiply the first term, which is the 5/6 x, by 6. And since we're multiplying it by a fraction, we're going to use the form of 6 over 1. So we're going to set it up as 6 over 1 times that term. We also have to multiply the 7 by 6. Now we don't have to multiply it by 6 over 1 because it's just 7 that's getting multiplied. So we multiply the 7 by the 6. Now on the other side of the equation we have the 1, which again is an integer. We don't have to multiply it by the fractional form of 6. We just multiply it by 6. And the last term, 1/3 x, has that fraction in there. So it makes it easier if we multiply it by 6 over 1. Now one thing that I see some of you doing is that when we multiply fractions, it is correct that we multiply straight across. But we sometimes wind up with some big numbers. So the easiest thing to do is simplify. In this case, we don't need to multiply 6 times 5 and get 30, 1 times 6 and get 6, and then have 30 over 6. The whole point of this is to get rid of the fractions. So look, we have a 6 in the numerator and a 6 in the denominator. They cancel each other out. We wind up with 5 over 1, or just 5x. Here, 6 times 7 is 42, 6 times 1 is 6, and here too, we have got 6 and a 3. They have a common factor. The common factor is 3. The 3 cancels out, becomes a 1. 3 goes into 6 2 times, so that becomes a 2. So when we multiply that out, we wind up with 2 over 1, or 2x. It's a much simpler way to multiply by canceling out common factors rather than just doing the straight multiplication and then trying to simplify later. Sometimes it's harder to find out what number goes evenly into both the numerator and the denominator to simplify a fraction. So simplifying it before you do the multiplication makes it a lot easier. The last thing that we want to simplify or get rid of to simplify our equation is by clearing decimals. Now we did some practice with multiplying by 10, by 100, by 1,000. And the easy way to do that, instead of actually doing the multiplication, is to move the decimal point as many zeros as there are. So here there are, to multiply by 10, we move the decimal point one place. So here we want to do the opposite. Since there are two decimal places, we're going to multiply that by 100. 1 followed by 2 zeros. 2 decimal places, 2 zeros. So we're multiplying by 100, but we found that we want to pick the decimal number with the greatest number of decimal places, which is why we choose to multiply by 1,000, because this term here has the greatest number of decimal places. So we're multiplying by 1,000. We're going to multiply every single term by 1,000. And here, since we're multiplying 0.76 by 1,000, it's got 3 zeros. We're going to move that decimal point 3 places to the right, making that number bigger. Multiplying by 1,000 makes the number bigger. So that's why we move it past the 7, past the 6, and we need one more place, so that's why we have to add the 0 and wind up with 760. We're multiplying the 3 by 1,000, getting 3,000. We're multiplying the 14 by 1,000, getting 14,000. And here too, we're multiplying the decimal number by 1,000. The number has 3 zeros, which means we're moving the decimal point to the right 3 places. The number of places matches the number of zeros. 1, 2, 3, so it winds up behind the 1, and we just have 1x, which can be simplified to just x. That's the first step, making it simple. Then the next step, and a lot of people don't do this necessarily. So the first thing you want to do is, if there happen to be variable terms on both sides, you want to get the variable terms to the same side of the equation. The way we do that is we pick one of them, doesn't matter which one, and we want to do the opposite to get it to the other side. So here we chose to get rid of the 15x, leave the 20x there. How do I get rid of 15x? I subtract 15x from both sides, and that gives us a number here and only one variable term. You could have chosen to subtract 20x from both sides. That would work too. The only thing then is that we would wind up with a negative number on the left side, which is fine if you're not scared of negative numbers and you don't lose your negative sign. But trying to keep things positive makes it a little easier also. The next step is to leave the variable term alone, the one we just isolated, and get it alone without the other stuff that's there. So here we have an equation with just one variable term, but it's got other stuff. So we want to get rid of that other stuff by dealing with that. I don't want to deal with the 20. The 20 isn't affecting anything. It's the other stuff, which is on the same side as the variable term, that we want to remove. So we subtract 12 from both sides. Then, once we have our variable term alone and on the something else on the other side, whether it's a number or a fraction, which it wouldn't be because we got rid of fractions up in that first step. But whatever we have here, even if it's a 0, we want to divide both sides by the coefficient of the variable term. That is the number in front of the variable. In this case, the coefficient is 5, so we divide both sides by 5. This is the step that a lot of you are missing. Once you get an answer, it doesn't matter what the answer is, you have to go back to the original equation, the one we started with. Plug that number in, replace the variable with the answer you got, and then work through using PEMA, P-E-M-A, parentheses or package, exponents, followed by multiplication or division, then that followed by addition or subtraction. When we're doing the multiplication and division, we work from left to right. When we're dealing with the addition and subtraction, we also work from left to right. And following the order of operations, we can then see if we get the same answer on the left side and the right side of the equal sign. And that's how you check your answer. If you don't match up, you know that you made a mistake along the way. So go back and check your work. Try it again. And once you have solved an equation, you can be guaranteed that you know whether your answer is right or wrong by checking your answer. Let me know if you have any questions. Good luck this week.